So my name is Kris. I will do the session about custom particle systems in geometry nodes. A bit about me: if I don't do Blender stuff or other computer-related stuff, I'm probably doing some playful or child-related things. So I like to do amateur gymnastics, a bit of swimming, mostly outdoor. That's what I like best. Building sand sculptures. I run this company called Lab 101 since 2010. Mostly doing creative coding projects. A lot of the time it was built with C++ in OpenGL. And at some point I got like really fed up with doing all the really heavy coding and too much writing actual code. And I started discovering Blender, which I enjoyed really a lot. I also enjoyed doing web technology again. So that's the stage I'm at now. I really like doing less of the coding, more enjoying making the work. A typical example of the type of project I like is the one below with the children in the boxes. So that's one of the things I made a few years ago. So I put children in boxes, you flip the carton, and then you create this gigantic mosaic of children in boxes. It's called the human pixel. Some of these projects, they get a new life by a commercial client. So that's what happened with this one. So the below is my project, and then above is also my project, but it's like for a festival, for a brand. That's like the output of the festival. I also do a lot of these large-scale projects. Mostly with generative graphics. And I'm showing this one because actually for this one we used Blender. Not for the actual output of the project, but more for the pre-visualization. It was super nice to have these skills, which I didn't have before, to pre-visualize how it would look. This is another project which is completely made in Blender. It's for fashion artist Flora Miranda. She asked me to make these data sculptures based on data she gave from her client, a financial company. And these entities, they grow closer or more further apart of each other, depending on the data you get. I also like very much making these, I call it satisfying motion pieces. At some point when it feels like this satisfying Zen vibe where everything like collides nicely, I'm really happy with it, and then I release it. But today we will try to make it a bit satisfying, but we will work around particles. So this is a particle system I made a while ago. These are actually two figures, human figures, who drive the particle simulation. I'm not sure if anybody can see the actual figures in there, what they're doing, or guess. Nobody sees the figures? So I can tell you already, like, these are hands. There's another hand doing like this. So it's actually an animation of two people swimming. And I just calculated the speed of all the bones or all the vertices, because I calculated on the mesh, and then of that speed, I spawn the particles. So for today, I like to do a live jam, which is what I called. It's also something I enjoy. I actually do that for like relaxing, just attaching some nodes together and then have some nice output. So I would like to work on one of these three. Maybe if we have enough time, we can like maybe extend one. But yeah, so the first one is the easiest one. It's just like spawning particles. Then the second one, I'm going to use a collider. I call it poor man's solution because it's not like the best way to do it, but like it's the most accessible, easiest way to do it. Then the third one is working on forces. So we have some attractors and also repulsion. So it's up to you which one we're going to make. So I will do a vote. I'll try to count it like more or less. So who's for the first one? Nobody? Okay, that's good. I'm actually happy with that because it's like a super boring one. It will be finished in like 2 minutes. Okay, number 2, the collider. Okay. Number 3, the forces. Okay. It's good because also that's the one with the most risk and the most things can go wrong, but we'll do that. Okay. Oh yeah. I have this quick warning. It will get messy. I have the tendency to like just add notes and add notes. So I'll hope I will remind myself to like clean it up like once in a while for you guys, so like it gets more organized. So the first thing we need is a setup. It's something we only do once. We will prepare one particle or multiple particles. We give it a direction, so that's the way it needs to go, and then we give it a speed. We don't use the speed in the direction because we don't want to calculate these numbers separately. It's easier. If you give just a particle one direction with also the speed included, it's not so easy to do other calculations afterwards. Optional, we can give it a lifetime. That's like how long it lives before it before we kill it off. Hits, how many things it hits, and then do something with that. So let's start with that. I already killed the default cube, so I don't have to make that joke. So I'll start with a plane, but it could be anything. Not sure if my interface is like big enough for the people who are trying to like following. Okay, I'll try to zoom in a lot. For this one, I will split my screen like this. Oh, shit. And then start a new node. Okay, so I will distribute points on faces. That's already like a good start. And if I run my timeline, like they just stay there, which is normal. But like every frame, I would like to like have different positions because otherwise the particles will always spawn from this point. So for my seed, the random seed, I will use the frame. If I run it now, so like every frame, it will spawn particles of this point, this point, this point. So that's good. But we want to keep the points and have new points every new frame. So I will add a simulation node. I hate it when it doesn't snap automatically, but I will kill this off. And I will join this one in. So now, as you can see, it's like piling up like points. At some point, your computer will crash because like so many of them. Make some space here. So this is already like a particle system. It's the most shitty one ever because they just pile up, but it's a particle system. It just spawns particles, and these particles, they will flow from here, the new ones, and they come back to the simulation. So what I want next is like the setup. And I will use stored named attribute. So this is actually, for people who do like coding, it's like making a variable. It's making a variable. The variable is, it lives on every vertex. So I call it, or no, I don't call it, but I give it the name direction. Really important, direction is like a vector, and by default you get a float. If you see at some point you see stuff moving like diagonally, it's probably because you're using a float and not a vector. So here I will add a random value. And for my x, I will start safe. And I always want to go, my particles to go upwards. You can do whatever you want, but like for this to look nice, I want to have this direction. So these are the minimum and maximum values. I will give it also a speed. So I switch back to float. Random value. We don't want to go too fast, so maybe 0.1, 0. Like you will see me like changing these numbers like really often. Often a lot of my things I make, it's like I think most of the time it's 10% or 20% making the thing, and then like 80% like tweaking all the numbers. I do sometimes also mark my my nodes with the color, just so I know, okay, this node is like interesting for me to tweak later. So that's that. So now we have like these numbers I can show you in the geometry nodes tab. So if I check my points, you will see they have a radius and direction. Oh no, sorry. So there's something wrong, but because my direction is like just 0.
You didn't change the name of the attribute.
Oh, good catch. So let's check again. Also with simulation, you often have to like rewind the timeline. So that's good. But then the speed is, yeah, we're all set. So the only thing I have to do now to keep things moving is like set the position. So to set position, use the offset. Get direction. Get the speed. Multiply them. No, not multiply them, because it could be like a problem because I'm using now a multiplier of like 1 dimension. So that could kill like the vector. So I want like the vector scale would be better. Vector mat scale. This will like multiply the speed with every part of the vector. Like this. Okay, let's go. Wow. This is also nice. Let me have a look. Yeah, it doesn't look like that. Yeah, so we'll keep adding stuff, I think. Okay, so I also want my timeline to be like a bit bigger. So 800. Then we could like run into troubles because after a while this will be like an infinite pile of points. So we don't need that. So there are like different ways of killing off your particles. You could like decide, okay, I just kill them off if they're like out of a reach, out of a box, or you can have like a counter. I prefer the counter, it's safer. Because if I miscalculate something and my particle drifts off to the far right, And I just check if it's like maybe above some kind of set value. Then I don't kill it off. So I will introduce an extra variable. I have to keep moving. So this one I will call life count. It's an integer. And then here at the end, you could also do it in the beginning, it doesn't matter that much. I will say delete geometry. And I want to delete everything which is above some number. Let's say 40. So rerunning. Yeah, it doesn't worry because the life count is just like 0. I'm happy for the particles that they're still not killed, but at some point we have to kill them. So how we do that? We store that same value again. So the life count. But then we add always 1. So now every time I run it, the value life count will increase. Check. Yeah, that's working. So if I lower this, the life expectancy gets like lower. That's nice. So maybe to clean it a bit, this we can already decide, okay, I'm going to put that in a group because these nodes are just hanging around. Make a group. I think the threshold is interesting to keep it as a parameter. Give it a name. So group threshold. So I can use it like this. Particles. Sorry, are people following along? Like, or I just give, because I'm going like pretty fast. I just noticed. So.
Maybe you can show the whole node.
Oh. Yeah, I will give like, because this is like the most complicated example. So the nodes will get like 10 times more.
Just control space in this window, and then you have full screen control space.
Oh, that's nice. You will get the file anyway after the end. If I control space, okay, that's nice. Okay, so that's good. So I think we can start already like with the forces. So I will make a UV sphere. I will join it in after the simulation, because I don't want to have stuff in the simulation other than the points. So I have the sphere. I will transform the sphere. I will also add a shape. It doesn't matter, but I really hate like pixelated and low poly stuff. Sorry. Oh, much better. So this number, that's actually the number where the sphere is. But I also need that to compare like how close are the particles to that sphere. So I will make that into a combined x, y, z. So then I can like pull that out later. Oh yeah, I skipped some slides already. Like we did the setup, that's done. Update, so you want to do like the basics, calculate new position, that's done. Update the speed, we didn't do that yet. Update direction, we will do that with the forces. Remove old ones, done. And then for attract repulse. So the idea is that the blue one is the particle, the green one is like the attraction force. We have to calculate the distance between these two and use that vector to steer the particle, either towards the green one or away to the green one. So if we use the green position, we subtract the blue one, then we get a vector, and that will be like, we will steer our particle towards it, but not like immediately. We will calculate like this in-between interpolated direction, then the particle will steer slowly towards that. That's the whole idea. Okay. So I have my sphere, I have the position in here. I have to make space again. Now, because I'm doing this presentation, I'm actually moving it like cleanly, but normally I just push everything in between. Like, then after a few days, I clean it up. So, vector mat, subtract. So this is my target, like the sphere, and I will subtract the position of the particle. For those who don't know, this position will be automatically filled in because it's a field coming from the geometry which will be linked later. Okay, so I've subtracted. Then I get this new vector, which is actually like the difference between the two of them. I'll calculate the length of that vector. I'll already put this one in here. So I will store like a new direction. So first I will take the old one. I will use a mix node. That result will go into the direction. Yeah, this is by far the most difficult part you will see today. So I have this new vector, which is the difference between the two of them. Then I have my old one, that's the vector the particle is going along. So now I will decide like how far should you go to the new direction or keep the old one? Because I don't want to have like all the particles going to that new direction, only a part of that. So I will check like if the particle is like really far, then I will not apply much force on it. If it's like really close to the attractor, I will apply like a lot of force to it. So it's getting packed already. So in here, I will say, okay, say my particle is between 0 and 1. So that's very close to like the sphere. Then I maximize the new direction. So if I do it like this should go in here, and this should go in here. I think that should work. Is that more or less clear, or is it like too abstract? So I'm using this map, which has as an input the distance between the particle and the sphere. And the bigger the number is, the more we like mix the new one in. So this one. So I see it's wrong. Right? Getting confused myself. So no, sorry, I made a mistake. I'm using the vector, not the length. This goes in here, like this. Okay. This should work. Let's try. It's a bit strong. So I'll guess I like this number is how much it will take from the new value. You see this slot? That's the one factor. If I make it maybe like this. Yeah, it's working a bit. Also, my particles are like too fast. I'm going to make this slower. So that's nice already. I think to have like a better view on it, we will move the sphere. So for that, we're not going to make ourselves too difficult. So I'll probably pull in noise. Yes?
So this is the position of the sphere of the surface.
No, it's just the center of the sphere. You could probably do actual detection with proximity to see how close the object is. But the sphere is like just like an object to visualize the force. So if I want to move the sphere around, I just going to add a noise texture. And it's complaining now because this one is all a field. But here, no, it's not expecting a field. In this slot, this transform slot, you see, it's a dot. But here, we're actually working with fields, like here, the incoming one. So if I make it a one-dimensional, it's fixed. So I will use my frame again. Probably have to slow it down a bit. So it's working, but it's like this very jittering effect because the scale is like a bit too much. This one also has to be lower, I think. And we want to scale now we get the opposite, it's like too slow. So as said before, a lot of times it's like finding like the sweet spot in the numbers. Oh yeah. No, I thought I made a mistake here, but it's not the case. I did make one here. I only need like X and Y. going to remove the outline. So it's a beginning, but it still looks like really bad. So this is good. Oh yeah, it's also a noise texture, goes from 0 to 1, but we want to go to like also minus. That's better. It's difficult to see if it's like working correctly. I also have to increase my my live count. And then they're very much sticking towards the sphere, not like releasing, because I think my attraction here is like too big. Oh no, it's 1. It's not so big. I think we have to like at some point have more gravity upwards or downwards to release them from the sphere. So we'll make some room again. So along the line, this direction gets like adjusted like multiple times on all these different factors, like the forces, the gravity. That's what we're going to do now. Oh, I killed it. Let me see what I did wrong. Here, this one? Oh, thank you. So now this stays the same, but I'm going to mix. This is like the gravity, so like I will slide this all the way to the left, so I keep my original direction the most, then a little bit upwards. So rewind it. A bit more. Still have the feeling something is wrong because they don't release. Yeah, for now I will keep this off because I feel something else is. Like here.
No, 2 marks, yeah, and then the last one.
Yeah, this is actually the force, so. No, I think it's good. Yeah, like it could be higher like this, that's good. So what we need is like, that's what I made in like in the real example. So we need some repulsion. So now we're attracting and everything is slowing down. So we need some repulsion, so we're going to build that. So actually, repulsion is just the same as the attraction, but like in reverse. So we will take this whole block here. Let me see. Everything except like the noise. So we made a group of it. Check, I call it force. So we have the incoming position of the force, you have geometry, so that's nice. And here we want to switch this part. So if we switch these two slots, you get then a repulsion. So to do that, I'll use a switch. Makes sense. So I'll take, so now we have attraction, so that's, no, like this. This is basically the same, but like switched. So the current one I put in the true slot, other one in false slot. So now if I switch this,
Should you be inverse to min and to max? So that's it's stronger when you are closer to the.
yeah, that's already in there, like the map range.
Yeah, should you inverse to min and to max?
I could also do that, yeah. But I could also do like this subtraction. I could also like reverse that. It's basically the same. Let me check again. So now it's attracting. It's still attracting.
Does it matter that the switch is a vector and the upper range is a fluid?
No, because I calculated the length of the vector.
You forgot to put the switch output into the mix node. You're only going the attraction force into the mix node. So you could connect the switch output
Yeah.
to the mix node on the right, where apparently only the upper subtract vector field goes in the B factor.
You mean this one?
No. The switch node on the bottom where you're switching between attraction and repulsion, the output
Yeah.
to the mix node on the right where the map range goes.
Oh, yeah, that's the one. Thanks so much.
You're welcome.
Okay. Yeah. Okay, that's good. I do have like a backup file, but it's really shitty to take the backup file. But also the remark from somebody else, you could also like switch these values. It's basically the same. Like, actually, these systems you can make it like in so many different ways. So now we have a force node which we can like switch to like attract and repulse. But let me like add these values as a parameter. So this one is the distance. So the first one is attract or repulse. The next one is the distance. And last one will be the force. So this is actually the force we're applying into the mix. So that's nice. So I'll duplicate this one. And I switch it. So this one will be, I think, the repulsor. And this one will be the attractor. So I will do a large distance in attraction, like low force. And then like when the particles get like close to the center, I will apply like more force. And I pull in the same vector. Does not seem to work again.
Sometimes you just need to restart the sim.
Yeah. Yeah, now it seems to work. I'm not worried about like doing something else.
Try muting the first one maybe, just to test.
Maybe
So this is the attractor.
the node group is used two times. You should press and choose properly to have a difference between the node groups.
Oh no, look, the no, it seems to. No, you can use it like this. I think it's a matter of like having the good values. So that's the repulsor. Maybe I forgot to connect some slots here. Check.
I think you may have to switch A and B in that mix now if you're selected.
Which one here? No, it depends. Then I have to switch it here as well. I think it's a matter of like having the correct values. So this one is like way too strong.
Didn't you have like super small distances before, like 0.03, and you might just everything is way too large right now?
Could be.
I think
Yeah, I will check my the one I made like an hour ago. So this is how it's supposed to look. I did it more or less the same. What I did differently with this one is that once they were like very close to the ball, I slowed down the speed, as you can see here. So I took the speed and I slowed it down. The switch is a bit useless for now. I had like two different values of like if it's an attractor or a repulsor, I use different slowing down. Or my idea was like make it faster if you are repulsing, like this. But basically it looks more or less the same, so I'm not sure if it's just the values or...
The map range, you connect it to Meeusen and the other ones.
Yeah, it's because I think it's because I switched the values here. I used the direction. Anyway, I'll leave it like this. So that's basically the same file. Probably did something wrong, something stupid. Let me check what else I had added in this file. The gravity I talked about. So the gravity just bends the direction upwards. You can also do it downwards. Then they will try to go downwards at the end. I talked about deleting the particles. A speed ramp is just I increase the particles a little bit in speed after a while. These are the forces. I added 2 of these moving balls. Yeah, the rest is basically the same. Yeah, so sorry for the bug which I can't find at the moment. I will go like quickly show you the difference between this one and the collider. So for this one, I did more or less the same, except that I added some turbulence here. Turbulence, you can like do that easily by adding some noise. So you just have a noise field, and you like displace one of the positions. So in this case, it's the y vector, or the y component of the vector. Oh, sorry, and the x1. And you add just a scale, and using this value, you can like displace the particles a little bit. Sometimes I just displace the particles when they hit something. That's a nice effect. So if they hit an object, then you displace them to give like this turbulence feeling.
Does it keep the speed?
It's up to you if you want. Sometimes also when I detect a hit, I just increase the speed or I slow down the speed. The nice thing, if you make your own particle system like this, you can like fake or like make it as cool as if you want. If you're using like a real physically accurate physics engine, it's much more difficult to like doing these crazy things. So how this collision works? It's quite easy, I think. It's not the best solution, but it works like most cases for me. I just check the proximity. If it's less than a certain value, then I sample the nearest surface, in this case the box. I sample the normal, and I'll use it as a direction. That's basically it. Like, if you want to have a real physics engine, you will probably want to like do this stuff like multiple times in between frames. Because now if the particles are going too fast, they will probably like go through the volume. So I don't think like a real physics engine do it like this. Yeah, another important thing about working with the particle systems, you always want to calculate everything on the points, never on the real geometry. So it's only here at the end where you like instance your real particles. So these are just points. If you would like calculate everything on the real particles, like real geometry, real mesh, you have your simulation is like, depending on the amount of vertex, like 10 or 20 times more heavy. So you just want to keep it simple. So collision was explaining this. Oh yeah, that's it. So thank you for coming. I have the files here on this tiny URL. And if you want to contact me, you can always send me an email or add me to your socials. Thank you.